Great. Well, first of all, I want to thank you all who traveled long distances and short distances to come to this seminar. I'm sure you're delighted that it's not as cold here as probably where you came from. And we hope you have a good time and we have a lot of discussion. So this is a very interactive forum to get started. So I wanted to say a few words about the new National Center for Biomedical Computing here at UCSD. You can see us here at the bottom, and the reason for that, we're the latest one to be funded, nothing else implied. And we have a lot of synergies that I'll present at the end with many other centers. So we have just started. We're in the beginning of our implementation of what we plan to do and some changes as well. So a little bit about the center. What's our vision? As you know, it's integrating data for anonymization, analysis, and sharing. And what do I mean by sharing? So sharing data. Today you have public repositories of data, mostly non-clinical, mostly at NIH. And everything, or most of the data, have to undergo data use agreements. So it's very hard to obtain some clinical data out there. And we want to make it easier for researchers to reuse data, many times collected under federal funding, and then make a secondary use of that data. So we envision for tomorrow annotated public databases. We envision that an informed consent management system may be in place so that more patients can contribute their data for public repositories, annotated repositories. And we also envision that that data can be transmitted over certified trust networks. And that is, you don't need to order hard drives and do a whole lot of maneuver in order to get certain data. Sharing data is not everything. There is also sharing of computational resources. So today you have a few institutions that have a wealth of computational resources and many institutions that don't. Good ideas are everywhere. So you would envision a time in which a researcher in an institution without too many computational resources could use and could share resources from here, for example. So this whole building, the Supercomputer Center, has tremendous resources that we would like to make more available to others. So what happens today? Computer scientists are looking for data, and the scientists are looking for computation on their data. Can we put those two together? How can we do that? How can we avoid duplication of pre-processing efforts? So there are public repositories of data. We obtain the raw data, we pre-process it, and everyone does the same thing. We don't share the intermediary products. And many times, as all of you in data mining know, pre-processing is perhaps much more work than the processing itself, than the data mining. So if we could shorten that step, that would be of great value. Again, massive storage and high-performance computing is limited to a few institutions. We would like to make that more available. So processed, de-identified, or anonymized, in quotes, because data can never be fully anonymized, but we envision that that can be shared. And we also want to do research on secure and biomedical behavioral data being stored and processed in the cloud. And as you know, that's what people say is the future, but is it secure? Is it enough? Is it good enough for personal health identified data? So what do we mean by integrating data? Two items: integrating data from different biological levels, in which we have the genotype, the molecular level on the top, and the phenotype at the bottom. In this particular conference, we're talking about phenotype. We're talking about clinical images that could be used for research, and how can they be shared. And so a lot of the effort today is on annotation of this data, and it's not on image processing in those areas, in which there are centers like Quran's that do that and are very specialized in this image processing and other tools. So we want to collaborate with those centers. We also mean integrating data from different institutions. And in here, I just have a few examples of the institutions that are involved in this center. So the VA at Tennessee, under the PI Michael Matheny, Brigham and Women's Hospital, under Fred Resnick, interventional cardiologist. We have several community partners, UCSD data, and also the UC-wide system through a consortium of all the informatics groups in the 5 UC medical centers. So the goal is for a researcher who is authorized to query data to be able to access data from different systems and get these answers back. As you know, and as you will be discussing today, there's a lot into this data matching function, and so there will be important discussions about that. So that's for the I, for the integrating. So what is the anonymization? Anonymization of records and of institutions. You don't want an individual to be re-identified. And in many times, you also don't want the institution that provided the data to be identified, because that could be used for purposes that were not intended by the data contributor. So we have effort in algorithms and processes to anonymize individual data and to anonymize institutions as well. So that's one of the A's. Important also for anonymization and important to our efforts is how do we integrate genomic information into patient records. As you know, genomic information, whole genome sequences, or even SNP arrays are very identifiable. They are by definition identifiable. So how can we do that? Can we still share records if we start including that information? So a lot of effort also is going on in terms of analysis and in how we can include that information that is anonymized, how we can compress the data since it's very large, how can we do queries on compressed data, because those will be more efficient, and a lot of other processes involved in analyzing genomic and phenomic data. So pattern recognition and the use of high-performance computing in order to do efficient queries. The other item, so the SH, the sharing, is very important too. And to that, I would say we want to share nationally, evidently, but we want to share data and knowledge wherever we can. So leveraging on other projects that we have internationally. What we think is the more we can disseminate this data, the information that comes out of it, the better we will be. Lastly, I wanted to say the National Centers for Biomedical Computing, each one of them has associated driving biological projects, and I'm just highlighting one of them here because it does have more clinical images associated with it. And this is a rare disease, and being rare, it makes even the more sense to share data and to aggregate data to do studies. It's driven by PI Jane Burns here from UCSD, who has an international registry of Kawasaki disease cases. There are specific aims that are more molecular, such as discover microRNAs associated with the disease, identify rare genetic variants that are involved in susceptibility and with outcomes, and also create a Kawasaki disease data warehouse and web-based data analysis system to facilitate discoveries in clinical and molecular data of this rare disease. So you will hear today some aspects of the imaging data warehouse for this biological project. So lastly, I would like to say something about I-dash synergies with the other centers. And in here, I made a very crude summary of the areas that I believe are at the most intersection of our projects and others. So ontologies with NCBO, led by Mark Musin, definitely is a very important aspect. So how can we do this data mapping? And we would use as much as we can of what has been already developed at Stanford under the NCBO. Tools for interinstitutional queries, the I2B2 project at Harvard is also very important for our efforts. So as I said, we want to share data, we want to exchange data. Can we use the tools that have already been developed there? Genomic tools, there are two centers that have a lot of developments in this area, one at Columbia and the other one in Michigan. And we believe there is a lot for us to learn from there and to make developments that are complementary and are redundant to those centers. Imaging, we have Ron's Anemic National Alliance and the CCB from Los Angeles. We think there are a lot of synergies here too. While we are focusing more on the annotation for sharing, there's a whole lot involved if you want to retrieve images by findings and other processes like that. And with Symbios, which is run by Russ Altman out of Stanford, we think there is much we can learn about modeling, about their experience in having different interdisciplinary groups involved in this process. So to conclude, I just wanted to introduce the project, the Integrating Data Analysis, Anonymization, and Sharing, I-dash, and to mention that sharing of clinical images is an important aspect of it, and I'm very honored that you would all come today to discuss this. And just welcome you to San Diego again, and welcome you to the center. We hope through this we will start developing a whole lot of synergies with each one of you, your institutions, and that you have an enjoyable workshop here. Thank you.